the most available switch in the market is IGBT, but that's also gonna get obsolete in future, because more advanced technologies are coming. So eventually, like, something better is gonna come up. The other thing that I wanted to mention was the purpose of this anti-parallel diode. It's anti-parallel diode, or it's also called freewheeling diode. And when it comes with MOSFET like this, it's also called body diode. So the purpose of this, as mentioned in the previous video, is, and I just also mentioned it briefly, is that when you have a load that is inductive, or is basically non-unity, it has non-unity power factor, when the voltage and current are not in phase, in that case, then we might have positive voltage, but the current be negative. It's either leading or lagging, right? So anti-parallel diode or freewheeling diode, it basically provides a path for the current that goes from the load back to the source, right? So that's the purpose of diode. If our load is purely resistive, this is not necessary, because voltage and current are going to be just in phase. But when you have non-unity power factor load, like for example in the case of RL loads or like motors, then we need to provide a path for the current that would be stored in the inductor of the load. So this diode would make sure to provide that. Okay, and the other thing that I wanted to mention is that both inverters, both kind of inverters or any inverter, it wouldn't generate like purely sinusoidal waveform that we want, right? So we need to have some filters here that would filter out the harmonics of the output voltage of the inverter. So like here we would have some LC filters that would filter out the harmonics, and depending on the type of inverter that you have, depending on the control method that you have, you might have like a certain harmonic, and then you have to design your filter that such that those harmonics are gonna be filtered out. Also, like depending on the standards that you are using your inverter in, like, so for example, certain standards asking for like THD, total harmonic distortion, to be less than something, or like they don't want to have like certain harmonics. So then you have to design your filter such that those harmonics are basically filtered out. Okay, so let's just also see let's also see a big picture of how the inverter is used. So they're like similar to DC-DC converters. We can use an open loop inverter, or like we can use it in closed loop. Okay, so here like I'm drawing like a closed loop inverter. So like we have a DC source, it's going to inverter, and we have a transformer to basically supply the load, or this can be also the grid, right? So we have to increase the voltage to the voltage that is required by the load or voltage of the grid, and there are some switches here. So, and also like we have a control mechanism here that would control the inverter, right? So we have to fire those switches, those thyristors or IGBTs or MOSFETs. We have to fire them, like we have to trigger them. So like this is basically taking care of that. Also, like this control might have some protection unit that would take care of some cases like overcurrent, over voltage, under voltage, undercurrent, and just like open the switch if needed. We also, as mentioned, like here, this transformer can be like our inductor. We also like have a filter. So this is basically an LC filter that would make sure the harmonics here are cancelled. So this can be a concept of an open loop control, right? We don't get any feedback from the actual voltage of the output. So if we want to have a closed loop inverter, we also measure the output. We make sure that our output compared to our reference voltage, we measure the error, and based on that we adjust the input to the inverter, right? So we also like this, we also have to have the DC source values. So like this one we need it for this case as well. Right. But here, like this is like the feedback that you're getting. So, and this becomes like a basically like a two-way path. So this is what we have. There are, based on the application, based on the voltage level, this DC voltage might be a low voltage DC. We can boost it up, can have boostage using a DC-DC converter, making it like high voltage DC, and then convert it to AC. Or we can just have DC low voltage and then invert it to low voltage AC, and then using a transformer having it stepped up. So that's also something I wanted to mention here. So usually we want to use closed loop in the cases that there might be changes in our load, or there might be some noises in the system. If we are sure that the voltage and the frequency of the load is not going to change that much, then we can use open loop. But otherwise, in real life, in practical applications, we want to have closed loop, because